All right, so today we are going to be reviewing our Conics section. If you want to refer to your notes from Conics, you may, or you may take some new ones today. First, we're going to look at circles and specifically identifying the circle. So if we're identifying the circle, we're looking for both terms being squared. We're looking that they have the same sign and the same coefficient. So that means we're looking for x and y to be squared. They're going to have the same number in front and the same sign. So they're both going to be positive. So if we look at example number 1 right here, okay, and we're looking at these two terms, notice the coefficients are different. So it is not choice number 1 there. If we're looking at choice number 2, we're looking here, we do not have any other terms being squared, so it's not this choice. And if we're looking at choice number 3, we are looking at both squared terms. Notice that they both have the coefficient of 4, and they are both squared, and they both are positive terms, so therefore this one would classify as our circle. Okay, so now we are going to look at writing the equation by completing the square, and then we're going to find the center and radius once we've done so. So to refresh our memory, when completing the square, we are going to need to know how to find that completed square, and that's going to be b over 2 squared. That's how we'll get that squared term. So I'm going to put all my x's together. I'm going to have 4x squared minus 8x, and then I'm going to have plus 4y squared plus 4y, and I'm going to kick this 11 to the right and it to become a positive 11. Okay, I'm going to change my color here so we can see things that are being added in. Okay, so we're going to have, notice that these two have the 4 in common, so we're going to pull that out in front. We're going to have 4x squared minus 2x. Okay, then this is the part where we're going to complete our square, so I'm going to switch to red. So we're going to take our middle term, which is negative 2, divide it by 2, and square it. And when we do that, we will get 1. So we're going to add 1 here. And when we add 1 to one side, we have to add it to the other. Now, I'm not just going to be adding 1, but I'm going to be adding 4 times 1, which is 4. So over here, I'm still going to have my 11, and then I'm going to be adding my 4. Okay, now I'm going to complete the square for the second one here. Again, these have 4 in common, so I'm going to pull 4 out. And we have y squared plus 1y. So we're going to be adding, complete the square. We're going to have 1 over 2 squared. We square the top, which is 1, and we square the bottom, which is 4. So we get plus 1/4. Okay, so again, we have to multiply by that 4 on the outside. So 4 times 1/4 gives us 1, and we're adding 1 to the right-hand side. All right, now we're just going to simplify here. So now I'm going to have 4, and remember when we take the factor of the inside, it's going to be x, and then we take the sign of the middle, which is negative, and then we divide our b term, which is that 2 by 2, and that is what gives us our factored part, plus 4 times, okay, so we're going to have y, it's a plus here, so we're going to put plus, and then we're going to divide our 1 by 2, and we get 1/2. And then those are squared, and they're going to equal 11 plus 4 plus 1, which will be 16. Now this is not in perfect form. We need to get rid of those 4s, but it's a factor of both of them, so we're just going to divide everything by 4. So when we do that, we get x minus 1 squared plus y plus 1/2 squared. And 16 divided by 4 is going to be 4. Now we need to identify the center and the radius. And our center, we take the opposite signs of what are next to x and y. So we're going to get positive 1 and a negative 1/2. And then for our radius, remember this is r squared in the original formula. So in r's, it's just going to be the square root of 4, which is 2. If you need help recalling what that original formula is, I'm going to write it down here for you. It is x minus h squared plus y minus k squared equals r squared, just for those of us that need some recollection on what that equation of a circle looked like. All right. Next, we're going to graph that circle. And when graphing circles, we use the h and the k and the radius to do so. So our center point here is going to be 2, -1. And our radius is 3, because the square root of 9 is 3. So I'm going to go over here and I'm going to plot 2, -1 on my graph. And then I'm going to count my radius up, down, left, and right. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. And then I create my circle. Hopefully you are better at drawing circles than I am. All right. So that's the circle. Next, we're going to talk about the ellipse. Okay, when we're talking about the ellipse, we're looking for both terms to be squared. Same sign, so they're both positive or they're both negative, and they have a different coefficient. Okay, that's the part that's different from the circle, and there's a different coefficient. All right, so let's see. Looking at the first, we have those two that we're looking at. They have both are squared. They are both the same sign because they are both positive, but they have different coefficients. So this one here is our ellipse. Okay, so let's look at completing the square for the ellipse. Just to recall what we're looking for the ellipse, the original equation is x minus h squared over a plus y minus k squared over b equals 1. These are always equal to 1. Now remember, there is a vertical and there is a horizontal ellipse. What I've just written up there is the horizontal ellipse because the x is with the a. If we switched the y minus k and the x minus h, then we would have that vertical ellipse. So we're going to complete the square here just like we did with our circle. So we're going to have x squared minus 6x plus 4y squared plus 16y equals our negative 21 because we're moving the 21 to the right side. Right, I am going to now complete the square. So we're going to have x squared minus 6x. The piece we're adding in is the negative 6 divided by 2 squared. So negative 6 divided by 2 is 3. Squared is 9. We have to add 9 to our other side as well. Okay, got to pull out the common multiple of 4 here. So I'm going to have 4y squared plus 4y. Completing the square, 4 divided by 2 is 2, and 2 squared is 4. So we're going to add 4. And we have to add 4 to the right side as well, right? No, not here. Not here. We're not putting just the 4. Okay, we have to bring that 4 and we have to multiply it back by the 4 in front. So we're going to actually be adding the 16. Okay, so we're going to continue here and we factor this piece here and we get x minus 3 squared. Remember, I just took my middle term and divided it by 2. Then we're going to add, keeping the 4 in front, y plus 2 squared equals negative 21 plus 9 plus 16, which will give us 4. Okay, and again, we need that 1 on the right side of the equal sign here, so we're going to divide everything we have by 4. So we get x minus 3 squared over 4 plus y plus 2 squared over 1 equals 1. So now we're going to identify the center and the A and the B. So the center here is going to be 3, negative 2. And our A, this is our A squared, so we have to take the square root. So we're going to get the square root of 4, which is 2. And B, square root of 1, which is 1. Now please remember we determine which type of ellipse it is by which A is larger. So here the larger term is 4, so this would be a horizontal ellipse. If this term had been a 1, then the y would have been the larger one. Okay, it's always the bigger A is telling us it's a horizontal or vertical, and that is just for ellipses. It does not happen the same way for hyperbolas. All right, so for graphing the ellipse, we need to use the center, the A, the B, and the C, which we get for our foci. Okay, and please remember for ellipses, the way we get our foci is going to be A squared minus B squared equals our C squared. All right, so our center here is going to be negative 2, comma 2. And our A is going to be 4. Our B is going to be 3. And our C is going to be 4 squared minus 3 squared, or 16 minus 9. This is equaling our C squared, which is 7. So our C is going to be the square root of 7. So we would take the square root of 7 and add and subtract to, this is a horizontal ellipse. Okay, so we would add and subtract it to our horizontal value to get our foci in there. So if we take our center point, which is negative 2, positive 2, and we're going to count left and right 4. And then up and down 3. And then our foci, I'm going to put those in a different color, are going to be plus or minus the square root to the negative 2. They should always be inside of your ellipse. So the square root of 7 is going to be between the square root of, it's between 2 and 3. So we're going to add about roughly 2.5 to negative 2 in either direction, so add or subtract. So that would put us at here and roughly there. And then we would draw our ellipse in. Again, hopefully you're better at drawing than I am. I kind of suck at it. Okay, then we have the hyperbola. And the hyperbola, both terms are still squared, okay, but they have that difference of sign. So one's positive and the other one is negative. So let's go back through our list here. For number one, they're both positive, so it's not going to be that one. For number two, we only have one term, so it's not that one. For number three, they're both positive, so immediately it's not that one. And for number four, we do have a difference of sign. That x squared is positive. So this one would be our hyperbola. All right, let's complete the square for this and again find our a and our b. So we're going to have x squared minus 4x minus 4y squared equals 0. So if we complete the square over here, we're going to have x squared minus 4x plus 4. So I add that 4 to the other side, and 0 plus 4 is just 4. Still minus the 4y squared, because we can't really factor anything out there. So we complete the square, and we're going to get x minus 2 squared minus 4y squared equals 4 squared. Then we're going to divide everything by 4. So we're going to get x minus 2 squared over 4 minus y squared over 1 equals 1. So our center is going to be 2, 0, because there's nothing next to that y. And then our a is going to be the square root of 4, which is 2, and our b is going to be 1. Now in this case, if we wanted to find the c like we did on the ellipses, it's no longer minus, it's a plus. So it would be a squared plus b squared equals c squared in order to find the c. So let's go ahead and do that just so we can see what happens. So we would have 4 plus 1 equals c squared, or 5 equals c squared. So our c would be the square root of 5 if we were looking for that part for the foci. Okay. To determine whether or not this is a vertical or horizontal ellipse, the positive term is always your a. So positive term, and that's what tells you if it's vertical or horizontal. So here, the term that is first is my positive term. Notice that the y squared is the negative, is the x. So this would be a horizontal ellipse. Okay, if it had been the y, it would have been a vertical. So the positive term is always your a. It does not always have to be the bigger term like it does for the ellipse. So let's look at the graph. So the center here is going to be 0, -2. Notice I flip-flopped because my x is on the right side there, which means this is a vertical ellipse because the y is here on the positive side. Okay, so our a is 4 and our b is 3. To get our c, we need to do our a squared plus our b squared. So we're going to have 4 squared plus 3 squared equals our c squared. So we're going to have 16 plus 9, or 25. So c will equal 5. So we're going to add plus or minus add plus or minus 5 to our y values. So let's go over here and graph what we got. So this is the time that we're actually making the box. So our center point is at 0, -2. Our A is 4, and we're going in the vertical direction 4. So up and down 4. And then left or right 3. Okay, this is where we now make the box. And we draw the diagonals in. Now, if we want to be accurate about the diagonals, we can just count. So we go down 1, 2, 3, 4 over 3, right? 1, 2, 3, 4 over 3. I'm going to be off my graph. So up 1, 2, 3, 4 over 1, 2, 3. We draw a line that goes through the box and both corners. Okay, and you're going to do the same thing over for these. Okay, and we said this was going to be a vertical ellipse, so it would hit the endpoints of our box on the vertical sides. It's going to be up or down like that. And if we add our foci in there, okay, we're adding plus or minus 5 to those y values from our center point. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those green points there would be our foci. And that's the hyperbola. Last but not least, we have the parabola. And so it's clearly going to be the one that only has one variable being squared. So that one is our parabola. We're going to, again, complete the square. Okay, so we're going to have the normal equation for this is going to be x minus h squared equals 4 times p y minus k. And it would be flip-flopped. That's the vertical one. It'd be flip-flopped for the horizontal. So the y minus k would switch with the x minus h. So we're going to have x squared minus 6x. And then we're going to kick everything else that's not with our squared term to the other side. So it's going to equal 2y plus 7. We're going to complete the square on the right, so we get x squared minus 6x plus 9 equals 2y. Oop, that should have been a minus 7 up there, because when I moved it over, it became negative. 2y minus 7 plus 9. So we complete that square, we're going to get x minus 3 squared equals 2y plus 2. So that's x minus 3 squared equals 2y plus 1. Okay, and if we're finding our pieces, we're looking for the vertex, which is going to be 3, negative 1. And then we're going to find the latus rectum, which is that number right next to the parentheses. And then we're going to find our p. And we get our p by taking our latus rectum and dividing it by 4. So our p is going to be 2 divided by 4, or 1/2. Okay. All right, graphing. Graphing, we have to find a bunch of different pieces. Okay, so our vertex point is going to be negative 3, positive 8. We get our direction by determining what our p is and if it's positive or negative. So let's get our p. Let's find the latus rectum first. That's that negative 2. Our p is going to be negative 2 divided by 4, so negative 1/2. Since the p is negative, that means this is going to be going down. To get our focus point, we're going to add our p to our x term, so to that negative, oh, excuse me, I'm sorry, we're going to add it to our y term because we want our focus to be going vertically up and down for this graph. So it's going to be negative 3, 8 minus 1/2. Now I'm adding the 1/2, but it's a negative 1/2, which is why it became a minus um, for our focus. And then lastly, the axis of symmetry is always going to be what your x value was if it's a vertical graph. If it had been a horizontal where the y was here, it would have been the y value that we had. So we would have x equals negative 3 as our axis of symmetry. So let me plot my points, negative 3, 8. My axis of symmetry is there too, at the 3. And then our focus point is at negative 3, 7.5. So that's there. Oops. And then we count our lattice rectum divided by 2 is how far we move away from our focus point. So from our focus, we're going to go over 1, and then graph our parabola from there. All right, so that's conics. After this video, you have quizzes, which can be found on Blackboard. So if you go to Blackboard and then go to Final Review, under there will be your quizzes as well as the code for the quizzes. I will be taking that for a grade. I hope you enjoy your weekend.